Okay, number 16 from the Larsen worksheet, and 16 and 17 are not too bad. The interval convergences are a little bit interesting, but this is my function. Again, my center is 0, so both of these have the center 0, as did 15 and 14 and 13, so those are nice. Not as hard of work to do those, but we're going to be adding things up, so that's the trade-off. So we have f of x equals 4 divided by 4 plus x squared. And this is pretty close to what we want. So we can just divide everything by 4 so we can make this a 1. And we have 1 over, and then we'll just double negative. And we have our a is going to be 1, and our r is going to be negative x squared over 4. So we can write this as the summation a times r to the n. And then we could break it up a little bit. The 1's not going to be an issue, so we can just make this negative 1 to the n. And x to the 2n all over 4 to the n. So that's a nice form. That's pretty usable. Now we have to figure out the interval convergence, and we want the absolute value of this to be less than 1. Well, we don't have to worry about the absolute value because x squared is always positive, so we just want x squared over 4 to be less than 1. But then if we want to deal with this, we can just multiply by 4. X squared is less than 4. Then if we take the square root, now we're going to again have the absolute value, because if you take the square root of x squared, you get the absolute value. So we have the x squared, the square root of x squared is less than 2. I'm sorry, well, the absolute value of x, that's the same thing. So again, we didn't really have to worry about the absolute value here because x squared is always positive. So we just wanted x squared to be less than 1. But then when we put the 4 over here and then we take the square root, we get back into the absolute value. So x is going to be between negative 2 and 2. So there's our interval convergence. So when you see these x squareds kind of just follow this pattern, because that's what works. Because you do have to get at this 4, so you have to take the square root. Okay, let's take a look at number 17. And this was h of x. And negative 2 all over x squared minus 1. This is... and I think they actually gave you this. Yeah, look at this on number 17. They actually tell you the decomposition. So this is equal to this. So they actually did the partial fractions for you, so you wouldn't have to do it. And then again, you could write this. This is already set up into our a over 1 minus r form, pretty much. This is just going to be 1 minus negative x. And this is going to be 1 minus x. So it's a real straightforward geometric series. A is 1 in both cases, and r is negative x, or r is x. So this is my r, this is my r, so that we have the two series. And again, we can add these up. And we can make this the negative 1 to the n times x to the n. And we can then we can rewrite it like this. And I should have a bracket around that whole thing because I'm summing up the whole thing. And then I can factor out the x to the n. And again, it looks very similar to what we had in number 15. As a matter of fact, if we look back at number 15, it was 1 plus negative 1 to the n, and this is just negative 1 to the n plus 1, which is the same thing by the commutative property. So it's the same series I had in number 15, so I can rewrite this as the summation n equals 0 to infinity of 2 times x to the 2n. And again, my interval convergence was negative 1 to 1. So you can see, actually, you can see the work over here in number 15, so they're the same. I guess you can see right there. Same thing. So same series. So I think that was maybe the point of number 17, to go back and make sure you understand that. So this is real handy up here, real handy.